Well, I'm Joe Williams. I work for a company called Cloud. Basically, we're a company that runs on top of CouchDB, and we're basically taking CouchDB and another project called Dynamite, which is based on the Dynamo paper, and we're basically smashing the two together and making a literally scalable CouchDB-based database.
Did you go to OpenSQL? Did you go to NoSQL East?
Yep. Yep.
So that the Dynamo as an application server distributor is really opened my eyes.
Yeah, it's definitely. So Cliff is a really smart guy, and so he's trying to open up Dynamite again, but we'll see what kind of happens there.
You have to leave Microsoft to open it up. So.
Well, even if he leaves Microsoft, I don't know if it's going to get opened up. So it's kind of a mess. So just with licensing and them getting bought by PowerSet getting bought by Microsoft and all that. So yeah, we're basically taking those two things and making a database as a service based on top of CouchDB. So my main job at Cloudent is all the ops and infrastructure stuff. We're still a small team. We're 6 total people, so I'm pretty much the only guy that deals with most of that stuff. So I guess the first question is like, how many of you guys run NoSQL systems, period? I do, so that's 2. And so the rest of you, do you guys all run on EC2 or SliceHost or some sort of cloud provider, or are you guys using dedicated hardware, colo, or managed?
Yes.
Yeah.
All of the above.
All the above? Okay. Fair enough. So, we got.
We're just counting the kind of capacity.
So we pretty much pretty much run solely on EC2 at this point, but that'll change, and we're gonna have different levels of service and stuff like that. But so most of the experience that I've had is dealing with databases on EC2. So the kind of 3 topics I want to kind of like go over during the session is just automation. So this is like configuration management. Squeeze in. So automation is like dynamically adding nodes, that sort of stuff. Configuration management. So if you're using Chef or Puppet or anything like that. And then like performance is so kind of related is adding more nodes to increase performance, tuning, disk tuning, so like file system stuff, read ahead, anything that sort of stuff, and then availability, which is kind of what we were talking about a little bit before, which is building availability into your application. So if you do run a database in the cloud and a machine does go down unexpectedly, what do you do about that, and how you build it into your application so you don't have those sorts of failures? So I guess the first thing is automation. So how many are using a configuration management system? So what are you guys using? Puppet. Everybody's Puppet. Okay, we're a Chef shop. So I got started in Chef very early, but it's all the guys that work at Opscode who make Chef used to do Puppet consulting. So they built Chef because they got, I think, mad at Luke. So so what are you guys' experiences with, I guess, first bootstrapping machines and getting them up to speed and added into your systems, basically? So what kind of experiences do you guys have?
I hand create AMIs and spin them up on demand.
Okay.
To do what, sir?
I hand create AMIs, and so I can then later custom scripts spin them up on demand.
Okay. So is it like, so you guys do scripts to boot up machines and then add them into your configuration management system, and then the configuration management system takes them from there? Is that kind of the idea?
Yeah.
Okay. So I guess I can talk about what we do, and what kind of the system I've built is, so Chef has a web interface which you can manage all your nodes that are managed in Chef, and so what I've taken is it's a MERB slice actually. So I don't know how much you guys know about MERB, but it's like Rails, and a merge slice is kind of like I guess kind of like a Rails plugin. I'm not a web developer, so a merge slice can go basically it can be an app inside of your MERB app basically, and so you can fit that into your MERB app. And so I built a MERB app around that. MERB. And so basically to do EC2 and slice host and EBS support. So while you're managing your nodes with Chef, you can also manage them in EC2 and stuff like that. So you have a web interface that kind of takes it all up for you. And so instead of going out and flipping to the AWS console and back and forth between Chef, it's all in one place. In addition to that, so if you're familiar with Puppet, you know, like cookbooks, and you have, you know, different, basically it's Puppet's a DSL for installing and dealing with all sorts of configuration stuff. And Chef, it's very, very similar. So since our system is built on Erlang, there's a cool thing we can do in Erlang, which is hot code swapping. And so what that means is you can change out code in a running VM and never restart and upgrade code inside there. So Erlang's got some really cool features with that, and they've been used for 20 years, so they're pretty solid. So what we do is, in Erlang there's an idea of an OTP application, and basically what that is it's a way of kind of setting up an Erlang application with different configurations and files that kind of build an application inside Erlang. CouchDB doesn't normally fit into this mold, but we've kind of retrofitted it and made it fit into the OTP, so we can do these hot code upgrades. So the cool thing is basically once we build a release, we can install the release. It has all the code that it needs, including the Erlang binaries and VM and everything. So we just dump this tarball on the machine and start it up. We use a run it. And for upgrades, we build an upgrade package, which is basically a diff between one release and the next release. And we put that onto the machine and run a few steps in the Erlang VM to basically upgrade that. And that's all automated. So basically we change a version number and we build a release for that version number. And next time Chef runs, it checks the version number, says I'm different, and then upgrades everything. So all of our upgrades are completely automated, and there's no restarts ever needed. So that's pretty awesome. So especially since CouchDB since it's a new project, it doesn't have a very good restart procedure, and so basically when it restarts, you're basically saying kill the PID. So there's not like a, you know, let's not accept any new connections, wait for old connections to stop, you know, that sort of a thing. So so basically it just kills it, and any data that's in transit, you've lost. So we want to keep restarts to a minimum. So so that's kind of how we do it, which is quite a bit different than I imagine most people, just because we have Erlang stuff and that sort of thing. So I guess we can move on to performance. So some of the stuff that we do for performance is Erlang specific, and other things are just like normal system stuff. So like, you know, for Erlang stuff, we build everything in native. So basically it's built for that specific platform, and it's not very portable, but it runs a hell of a lot faster. So, and since we're using, you know, the same AMIs and for everything, and you know, that sort of a thing, so it doesn't really matter to us. So, but it runs much faster. As far as like just normal system performance, we make changes to the sysctl, and we use XFS, and one of the other things we use
So sysctl stuff, you can boost performance in the EC2 instance.
It's mostly network and connections and open file handles and all that sort of stuff more than anything. So it's, you know, allowing more memory to do the TCP stuff in the kernel and all that kind of stuff. So just basic networking and file handle stuff mostly.
How big of an impact was that?
Well, the file handles are pretty huge because once we get to a certain number of connections, we're kind of screwed. So,
Okay.
but networking stuff it's give and take. I think it'll make a bigger difference once we run stuff on real hardware, and we're not limited to, you know, I don't think EC2's network is all that great. So I think it's a bigger limitation than the actual parameters and CCTL.
So you're planning to go to hardware then?
Eventually, yeah. So right now we're running all on EC2. I think at some point we'll have a blend of EC2 and real hardware, and if customers want us to go to, if they want to have their own cluster on their own hardware, we'll probably do that too.
Right.
So it'll be kind of a blend of all sorts of stuff. So, but right now all of our customers are running EC2, except for one who has a single server that they're testing on AFS. So.
Imagine you'll be able to fairly easily come up with an algorithm to determine the customer is large enough to warrant
Sure.
it suddenly becomes worth doing the hardware.
And some of that's going to be up to the customer on
Okay, sure.
what kind of
Yeah.
performance aspects they want. Because with performance, so like I can give you some like details of like what we see is we see EBS is slow as heck.
Mhm.
It sucks. And and what I was getting to was that we run it in RAID 50 across 6 disks, and that's for redundancy because those things flake out. And like a couple weeks ago, we had a disk.
6 EVSs though, or
6 devices,
Okay.
and use an MD admin to create a RAID 50.
Right, okay.
And that's for redundancy, and it does get a little bit better performance. The redundancy is key though, because as I'll get to later, is we'll have strange happenings, you know, with EBS, where we'll see a disk usage in our Munin system that just flies up, and there's no good reason for it. And it's just one disk; it's not all 6, you know, that sort of stuff. A couple weeks ago, we had a situation where a device existed in dev, but was detached in the API. And you do like, I don't know if you guys have used MD admin, but if you do cat proc MD stat, I think, or status, it gives you the status of all the RAID devices, and that just hangs.
Huh.
Because like the OS thought it was there, and they couldn't actually talk to it, and it was a complete mess, right?
Wow.
So what we ended up having to do is we had to like basically detach everything from that machine and reattach it to a new machine and get the customer back up again. And so
Bad EC2 EBS bugs. Did you
Yeah.
file that one?
yeah, they said it was multiple hardware failures that caused it. I was like, awesome. Thanks a lot. So I wish they did a better job of detecting those and like, you know, maybe mitigating them rather than being reactionary to it.
Right.
But I think that's just kind of the way things are going at this point. I think
What I've seen inside AWS is they're running a fireball in between all their engine effort trying to work on keeping the thing from falling over as they scale
Right.
it, and then the other
Very accurate, yeah.
go back and clean things up.
yeah, exactly. It's I think that's probably pretty accurate.
If you talk to their development team, that's pretty much what they'll tell you.
This is doing everything they can just to keep it rolling.
Yep.
It's amazing. So I know this. I'm sure it's growing much faster than they expected. I imagine, or
Yes.
much further than they planned for. At least.
Yeah. Well, in fact, I talked to them about their monitoring services just to run it, and they were basically that was burning out.
The monitoring services having scaling issues. with
Right.
that.
Yeah.
And also they're hitting capitalization issues, just they can't actually buy underlying hardware fast enough anymore.
Yeah.
Their suppliers are, you know,
How many servers do you want? I mean, you want 10,000 servers tomorrow?
and how many the next day.
Yeah. So so those are the kind of issues that we've seen that are kind of strange and dealing with this sort of stuff. And I think the key here is running a database in the cloud is a lot different than running on dedicated hardware you got control over, right? And there's lots of reasons for that. So like the stuff that we're talking about makes it easy to run a database in the cloud. So like automation and stuff like that, being able to boot up machines whenever you want to, it makes it easy. So like, you know, the amount of time it takes you to get from nothing to a handful of machines is way smaller than it used to be, right? You used to have to order from Dell or whoever, wait a couple weeks. Once you get them, you got to install, you know, using, you know, if you're good about it, you have, you know, Cobbler or Kickstart or something. And if you don't, you got to sit there with a CD and, you know, put those in there and until you get the machine up. So like So like, there's good things about it, but there's also bad things. One of the other issues we have with performance is even within an availability zone in EC2, we get different machines, and those machines have different CPUs and stuff like that in them. And so one of the things that I found was we get way slower performance on the AMD Opteron 270 machines according to CPU info, and than we do with the Intel E5432 or something like that. I can't remember the number, but the performance difference is probably 50%.
Wow.
I mean, it's a big difference. Like, at least from performance in cache. So like, this is like performance that we see on our database versus running, and we do it on SuperPi, and it's a big difference too. You know, it's very we see it on CPU, and then we see it on I/O. Like I think it was taking 100 times longer to do some of the stuff we were doing on cache on those machines than it was on others. So like, this is under load. So like, it's crazy, right? Like, you don't expect those sorts of performance differences when you're running in the same availability zone or on a bunch of machines in the cloud, right? You expect the cloud to be pretty, you know, all the machines to be pretty similar, but in this case, they definitely aren't. So, but the CPUs I think are maybe 2 years different. Like, I mean, one's 2 years older than the other. So like, it's just the way life is.
But
So.
then application should compensate for this type of differences, and how you do that from application?
That's really difficult, right?
Yeah.
I mean, detecting those sorts of differences is difficult. So like, you know, detecting load on a server and shifting things is difficult. It's difficult to, you know, build into an application, obviously. So.
Because you're using your task on one side, but you make it way more difficult on another side. When you deploy in cloud, yes, you do have agility and kind of acquiring hardware and deploying hardware, but you stuck on supporting ever increasing complexity of application.
Right.
And so is cloud even, at least in ES2 level, is production ready?
It's a big question, right? I mean, we're doing it. You know, there's lots of people running stuff in the cloud, right? And that's a big question. I think it's yet to be answered, right? I think it works for a lot of people, and I think like what we're finding is like to give you a performance example of like the difference between running on the cloud and running on a dedicated server is so I did performance tests with a single machine on EC2 and a single machine software, and so the EC2 machine, this was just using just one EBDS device and CouchDB, like vanilla CouchDB. I think what we saw was basically a 4x increase going to real hardware. So yeah, I think it was for writes. So this is like 200 requests a second on EBS and EC2 versus 800 writes a second on not slices, but software using real disks. I mean, that's for us. That's the biggest thing. Like, the biggest thing that affects our performance is disk. So the faster we can get the disks, the faster we're going. So it's as simple as it is. So yeah.
So, real quick one. So early on, you mentioned things, for example, the similarity between machines.
Right.
And so 2 ways that I've dealt with that have been, one, making sure that the machines are doing as much pull as opposed to having things pushed to them, so they can pull things off from some queue at the rate that's natural to them. So that way you don't have to tell the machine how big are you.
Right.
The other part being, if you do have to make a decision, basically coding up some algorithm that either lives in your automation recipes or in some other startup script that has the machine inspect itself. You know, look at things like BOGO MIPS or memory or whatever, and try and automatically configure like a say number of Rails instances or whatever else on that particular hardware.
Sure.
In fact, running exactly one of those right now for
Good.
your 6 memcache daemon. Just start an EC2 up and it will introspect and figure out.
Okay.
But mine's pretty simple. It's how much memory do you have? How big are your block devices?
Oh, okay. Right. Cool.
No, I think that's important, right? So I definitely like these are problems that we didn't have before, that we now have because we're running in the cloud and because we're running on servers we don't know anything about until we boot them up. right? And these are the kinds of things that we have to deal with now if we're wanting to go that way. So for us specifically, like moving off to real hardware is something that we're going to have to do because we just can't get the performance, and we're going to end up buying so many more EC2 machines than we would have to buy real hardware.
Mm-hmm.
That it's just not going to. It's going to end up not being profitable, right? So you're going to, we have to buy, to get the same performance, we have to buy 4 times more machines. It just doesn't make sense.
On the other hand, I've noticed that people tend to underestimate ops costs.
Totally.
Yeah.
That's
Typical.
why people, it's, when I was first pitching AWS to people, going, this is kind of expensive, and having factored in the cost of, you have your 850, but I see so few times where people factor in the cost of having the knock monkey on retainer to go put the new disk in when it fails.
Sure.
The cost of, you can buy your internet connection, but can you buy one like Amazon's?
Right. Yeah, and I mean,
if you're super CPU bound, it makes sense to go off to your own, but
right.
most people are not as CPU bound as they think they are.
Right. And there's definitely lots of choosing that goes along with picking a data center and stuff like that. There's lots of stuff, like SAC 70 and whatever else you gotta like deal with in those situations too. So
as well as mixing and matching too. I mean, so you mentioned, for example, having some things running on hardware and some things going in the cloud.
Right.
That's turned out to be really useful for me in cases where there's some situations where it totally we know that there's going to be a minimum level of performance that we need to maintain, and it's going to need this many machines. Might as well get buy these out servers.
But then you have to factor in you're paying the transfer cost back and forth instead of having the free transfer cost.
So that's one part, but the other part is if you can partition tasks in a certain way. So basically shoving any kind of things that are bursty towards the cloud can make that worthwhile. So for example, you need a big job that needs to be done quickly, but it's still just a job, then you can throw it at the cloud very easily without worrying as much. But you're right, transfer costs are annoying.
I mean, that's what's like the allure of like something like Hadoop or something like that, right? Is you do all the data processing locally to that machine, and you never have to worry about it. And that's something we've built into our product too. So CouchDB has an idea of views that are incrementally built over an entire database. And it's based in JavaScript. So you write a JavaScript MapReduce, and it builds over the entire database. We're doing the same thing with our views, except each view is built locally on that machine, and we have a view collector that collects all the views together from out their cluster.
Huh.
So yeah.
How are they shipping out their views?
Sorry?
So how do you get one of them to generate views and have another one collect just those? Or is it just picking it up as this one generated in your data?
I'll have to ask one of our early guys. But yeah, I deal with some of that stuff, and I've written a bunch of Erlang, but I didn't work on the view stuff. So, but I can put you in contact with our guy who did. So,
okay. Cool.
If you're interested.
Do we know the open virtualization format that's supposedly coming? That's like universal AMIs that you can just deploy.
There's
on
the file standard's been set. There's part of the committee that to write that thing, and Rackspace has said they're committing to supporting it. Network.com was going to before that turned into a shambling zombie. A couple of the other smaller cloud provider startups, VirtualBox, Zen, etc. The invisible gorilla in the room is that Amazon has been conspicuous in their absence and all that stuff. But yep, the AMI format is a broken Zen format. It can be transformed back and forth to Zen and to the new standard format very simply, and we will see if Amazon decides it's advantageous for them to start supporting the new format or not. If they don't, other people will use converters.
Right. I think who already has a converter.
They're not hard to write.
CloudKick, I think is the name of it. It's a sister company in Y Combinator with our company.
It's got 50 lines of code.
They're able to convert EC2 to. That's not good. they're able to. I think they have their web interface. You're able to convert from EC2 to slice host, I think, which means you can convert to Rackspace too. So,
Nice.
so yeah, check them out. I think that they're writing their front end's in Python, I think, and they're writing this thing called libcloud. I think it just got onto Incubator at Apache, and basically it's a Python library that interfaces with all the cloud providers.
That's similar to Eucalyptus then.
This is just deals with all the APIs.
Well, it's kind of what Eucalyptus is supposed to wrap up.
Well, I thought Eucalyptus was more of like build your own AWS in your data center, right?
Yeah.
That's my understanding. So
So Eucalyptus would implement the libcloud interface.
yeah,
That's what
Eucalyptus
it's all
Eucalyptus implements the EC2
like.
interface, and libcloud deals with all the client-side API stuff. So basically, you have one library you can talk to talk to all the cloud providers, which is pretty nice. Because so like one of the things that we do is rather than implementing a API or so like we have multiple systems. So our front end JavaScript and Python. The chef stuff that I do is Ruby, and rather than dealing with multiple cloud libraries and both languages and dealing with all that stuff, but what I've done is basically kind of a bastardized version of JSON RPC and AMQP. So basically, both front end and our deployment system can throw JSON into RabbitMQ, and I have Ruby processes on the other side that basically shoot those out to the cloud and boot up machines and take care of detaching, deleting.
As a
devices
system for RabbitMQ, has anyone else used? Shit, I just forgot its name. I was hacking it yesterday.
ActiveMQ?
Next.
Scale? Kestrel?
Crazy Brazilian guy's been cranking this thing out.
Redis.
Redis.
Oh.
I haven't used Redis, but everybody I've talked to really likes it actually.
It's developing an ecology of consultants that work on it. It's GitHub.
GitHub put their queue system is on Redis. So
yeah, they actually
engineer guys
published a
really
great article where they said they started with RabbitMQ and went through each of the kind of Ruby queuing systems until they broke it and moved to the next
Yeah.
one. And now they're on Redis with some of their own additions to it.
Yeah, it's called Rescue.
What is the spell, guys? R-E?
Hmm?
Redis. What is the spell?
Redis? Yeah, it's
kind of like it's kind of like a really rich memcache.
It's super rich memcache kind of idea. You can store everything in memory. It is persistent too.
Semi-persistent.
Async.
Yeah, it's
Async.
async.
If you have a catastrophic failure, you can lose the last few seconds, whatever it was doing.
Right.
With no rollback.
That's still a hell of a lot better than losing everything with Memcache.
Yes.
As far as I know, all the commands and stuff to put and
There's
pop and everything,
yeah,
everything's
There's push, pop, pin, prepin. It's got high performance queues in it.
yeah.
It's got
And
sets
they got
and-
lots of stuff too. Yeah, it's like they have data structures in there, so you can like do lists and stuff like that. I think all the commands are atomic too. And I think so. Yeah, so it's pretty cool. So
it has some interesting scaling stuff to it. It doesn't scale to as many simultaneous clients connecting to it as Memcache does. And under the hood, it doesn't multi-core or multi-thread. It's one process running a high-speed event loop. Which is that's how he manages to handle the atomicity. Is that whatever order you get to it in is the order you get to it in. Which means it's you put on a 4-core machine. One core is running at 100%. One core is at 50% running your operating system. And the other cores are idling.
yeah.
But you can do the consistent hash that you can do with a Memcache if you set your primary keys up right.
I think they're trying to make that easier too. I think there's stuff in the pipeline to make that easier. So
Everyone's trying to make consistent hash easier.
yeah.
Guys, may I ask a question which was, sorry if I sound ignorant or anything.
Okay.
So performance. I always wonder with cloud and with also these bumpy performances which you can get from different devices. Is it any way of having between your application and cloud itself some kind of buffer or like cloud proxy? The sole objective of which will be select or discard devices from the cloud to assure, so you can, for example, I want to say that I want, yes, I know I will be getting less performance from local machine, but I want to know, I want to make it like solid, predictable.
Predictable, yeah. I don't know of anything like that. If you can make it, I bet you make money.
Okay.
So there's an idea, guys.
Should
You know,
we give you a royalty?
But that's hard.
I'll take royalties.
So you're kind of saying you would like to use the cloud when it's necessary. So if load becomes overburdened on your local systems, you have the resources to do it.
Yes, it's one way to look at it, but
I think what he was saying was you have a baseline number of servers, and I want to know how much performance I'm going to get, and if I'm not getting that, I need to add more servers, right?
yes, or basically, so instead of throwing yourself at the cloud, at the mercy of the cloud, and getting wavy performance for whatever
Take
service.
it back.
Yes, so you want assurance because in business world, you know, you've been asked how much you can deliver with your servers.
I've seen some cloud applications that get that smoothed out implicitly in their design, where they just is the rules that decide whether to spin up more servers have to do with the load on servers or delay on if your processing queue is increasing in length, then more servers will be spun up, and you don't instead of trying to predict, well, this server is consuming work items at this rate. Instead, you have some global set of work items, and you're just monitoring how quickly the whole tank is draining.
I think that's the premise behind RightScale and how they actually make their money is that they have their auto scaling based on those kind of metrics, so that when they see that you're starting to lag in a certain area, you start spinning up new instances, and they give you really rich interfaces to actually deal with that. And of course, you know, they charge you a nice fee on top of it for managing that. But if that's what you're really looking for, then that's kind of one of the areas where they've shined.
I think companies like Heroku do that. I think Engineer might have something for like, you know, Heroku and Engineer both do Ruby stuff, and I think both of so Heroku's like completely in the cloud. Basically, you check in some code into their interface, and you don't know where it exists or anything like that. You just know that it's out there running.
That really is the cloud.
Right. It's like completely ambiguous, right? You just put in the code and it's out there running somewhere. And I think they have that sort of stuff built into their infrastructure.
That's one way to not see the inconsistencies.
Right. And that's kind of what we're trying to do, right? Is you put your CouchDB database into our system, and you don't care about where it runs. You get about the same performance every day you ever hit. So that's the kind of idea. I think Engineer does some auto scaling stuff too.
Yes, there's the auto scaling stuff built into EC2 right now. Right now it scales only on memory and disk I/O.
Yeah.
And the thing that I have heard do not formally know that there'll be an API, an extension to EC2 API real soon now that will let an EC2 instance to start generating arbitrary performance metrics. So you put to the 169.255 address some number on a regular basis, and you can set up what's their obviously CloudWatch. You said and you just have CloudWatch rules saying that when the performance numbers look like so, start more instances, and it doesn't have to worry about what so is, and so you could start putting numbers to just how many Erlang reductions a second you're doing, or how big the listener queue is on a web server, or that sort of thing.
No, I think a lot of that kind of stuff is definitely important. What was I thinking? Along the same lines, I think AWS is also going to have guaranteed I/O at some point. I heard some stuff about that. Basically, you get guaranteed level of I/O ops. So, you pay for that, obviously.
The other thing I've heard whispered is that eventually we'll be able to start just leasing cubic meters of space inside Amazon's data centers.
Oh, really?
Kind of gives you the best of both worlds there. You have to here are one of the 4 kinds of servers you have to buy, and their knock monkeys will rack them and start them up for you, and then they look like EC2s, but they're your hardware, and they're your hardware, and they run inside the centers, so the transfer charge doesn't eat you.
That's awesome.
But should you put it in each single Amazon data center?
See, I've just repeated to you all of the rumors I have heard.
Ask more, few rumors.
I've heard that as well, so, yeah.
So, I mean, if they start doing that, I mean, that's going to be pretty awesome, right? So,
Yeah.
Instead, probably what to do is they'll probably start charging you by the cubic meter and by the watt consumed. AWS likes microcharging for the actual operational costs.
right. Like, if you boot up a EBS device, they don't charge you for actually booting it up or anything. It's how much disk space you use on that device.
And the I/O ops.
Yeah, and the trick, I think one of the tricks there is you never know what your bill's going to be at the end of the month, right? Like, depending on how much you stored or how much you wrote, you never actually quite know, right? And so I think there's a ambiguity there that they like to play on, I think. So.
I think part of it is they don't like to. Their business model is they charge you for everything that costs them anything. There was a couple of smaller attempted cloud startups have occasionally tried doing things where they have freebies and minimum buy-ins, or you do this and it's free, you do that's expensive, and I would always sit down with each one of them and take their freebie part and rewrite a MapReduce system on it. So make sure nothing is free that costs you money, because there are many people smarter than me who will do this.
Right. It's like, I'm only going to use it to this point, and then I'm going to shut it down. Right? Just only use the free stuff. But as far as consistency goes, like, I don't know if you guys know, but Supercomputing 09 is here this coming week, and that's part of the reason I'm in town. I'm just from Seattle, so I just came down. But so yeah, there's lots of talk of high-performance computing in the cloud, right? And I think one of the big issues there is consistency and performance, because when they run a job, they need to know how long it's going to take to run that job, because there's scientists waiting on the data. And same thing with the amount of data load that they have. They're producing, sequencing, is like terabytes of data, right? And they have to have somewhere to stuff that stuff, and then they have to do processing over it, and they need to know how long it's going to take. They don't want to shove all this data out to EC2 and then wait for it to come back, right? Because if it's a terabyte, it's going to take, 2 days probably to write all that out there or something? I don't even know.
Races and quickly they can sort of terabyte.
So that's, I think one of the interesting things that I've seen is like stuff, I think Cloudera had a post about using Hadoop to do genome sequencing kind of stuff. And they're like, we just booted up, 100 machines, and it got done in 4 hours, whereas normally it's 40 machines, it's 100 hours, right? Something like that. It's pretty interesting. But I think one of the interesting things there is having a HPC infrastructure that's local, and then at a certain point it flips and starts throwing stuff to the cloud. And I remember reading something about that, and that's pretty interesting too, because you're doing all as much as you can locally, and once it reaches to a certain saturation, it starts pushing stuff to the cloud in order to get the job done in time. That's a pretty interesting idea too. So.
And the cloud offers, if you can actually set up your systems that way, offers great headroom, right?
Right. It's totally flexible on the top end because you can just do whatever you want.
And all the transport times don't kill you on that job.
Sorry?
Yeah.
All the transport times don't kill you on the job.
Absolutely. So I mean, obviously your data set has to fit that, because if you have huge amounts of data, it's not going to work, right?
Yeah.
The data locality kills you.
Has anyone used the S3's physical data transport yet?
They're sneaking that?
I read the specs on it and was really impressed by it. I haven't talked to anyone who's used it.
I haven't used it.
That's another great example of Amazon charges you for only what the service consumes. For the SneakerNet load, they don't charge you by the megabyte transfer. They charge you by how many seconds your drive sits in the loading cradle.
Wow.
Interesting.
Which is in your interest to get the fastest device possible.
All right, so I guess this is a few minutes on the last one. So availability, we've kind of talked about this already with flaky EBS and flaky machines. So I mean, for us, ours is a cluster. So basically we have, it's quorum based. So if we have 3 machines and our read quorum's 3, then we can read from, because we're gonna have the data, right? So the guys running, SQL and stuff like that in the room, what do you guys do?
Multiple read slaves. I've seen people do master-master between 2 EC2 nodes. I think a lot of the really complicated, a lot of the really painful multi-read slave configurations are about to go away by being replaced with RDS.
Yeah, you asked this earlier. Who's using RDS? Has anyone tried it out or anything like that? Like, I don't know anybody that has either. But
I'm connected to it.
yeah. It just looks like MySQL, and you don't know how many machines it's running on, but it's out there, right?
Yeah.
That's basically the idea.
It's interesting, is RDS, they bill you like you're running a MySQL instance on an EC2, but if you work it out, the ops memory you get per percent, they're providing you with a M1 large and charging you for an M1 medium.
Oh, really?
So that's your you can build something like RDS out of MySQL instances yourself, but it's the bill is going to be less to use RDS.
Gotcha. So, kind of the things that I've learned, at least working for Cloudit, and because before I worked at a dedicated managed hosting company, and so like it's completely like kind of turned on its head, right? So like we always had machines, and if anything went bad, we replaced it, and that sort of thing. With this, with cloud computing, I think it's way on the other side, which is if something goes bad, you throw it away. And I think that's one of the advantages of running, a system like a lot of the NoSQL systems have, the basic clustering ability like Cassandra or which is Dynamo based, and our system is Dynamo based.
Node Foundry, throw it away.
Yep, exactly. So like, rather than trying to save machines, you throw them away. And I think this is a kind of a definitely a mind shift from what we're used to, right? So
that's also why I like spinning up I'm creating my own custom AMIs, just because starting up a stock Ubuntu or whatever, and then loading the install scripts onto it to turn it into something. When,
right.
when I have to throw a node away and start another one, adds 15 minutes to the start.
Right.
Whereas if I rolled my own AMI, it comes.
I would say I would check out definitely something like Puppet or Chef or something like that then, because so like basically our process is like it's all done via a web interface. So like basically I've built a web interface to build out a cluster essentially. So I put in what AMI I want, and I use just the Elastic AMIs, just so standard Ubuntu AMIs, and and what size and what availability zone and what role they are. And basically all a role is it's a collection of cookbooks basically that gets the machine up to the point where it's ready to be added to a cluster basically. And I can say how many nodes I want, and basically it'll start all those up, add them to Chef, get all the stuff ready, and I have a cluster. Basically all I need to do then is add those all to our load balancer. And so that takes 15 minutes to get all those machines up. I mean, I've done 10 at a time before. That's pretty fast, bootstrapping.
That's a good question. Is like what's the predictability of spin up time in the various environments? EC2, I've seen radically different. Yes.
Right. In the early days, it would take an hour and a half before you got your start alert.
Right.
Now it's usually just a few seconds, but I've had up to 5-10 minutes.
Yeah, I think the slowest that I've seen is probably 10 minutes. The fastest is 30 seconds. So
All you need of course you're trying to start. When you say start 20 M4X large, you may wait a while.
yeah, it may take a while for them all to get up, right? They'll get you'll see them incrementally coming in, and then eventually they'll get all in. But there's definitely a lag, especially when you're starting up a lot of them, especially when availability zone is getting full. So I've seen plenty of we don't have enough space left in the availability zone areas.
That may have actually been, I've actually seen it take 20 minutes, but that may have been that problem.
Right.
Where it's basically like, oh, gotta be in that availability.
Yeah. I know at least in the Ruby libraries that I use, it'll return back the error of whatever EC2 tells them. And so I see ones that say insufficient space and availability or something along those lines.
By the way, you do know that you get charged for those queries.
Do you?
Not a lot. I think it's like a nickel for every 10,000 EC2 status queries.
Oh, really?
But this was just to keep people from doing the start inside EC2, try to start more nodes up, and then in a really tight loop.
Refresh.
Just hammer away at it until they're all up. So
Right.
you should do a test and exponential back off.
Yep.
Try immediately. Try every 5 seconds for a minute. Try every 30 seconds for 5 minutes.
All right. Well, I'm gonna wrap things up, but basically, so I think kind of along the lines of availability is I think systems are going to have to change into systems that you're able to drop things off and be able to add and remove stuff dynamically, which is definitely difficult with MySQL or anything replication based. I think that's going to have to change at some point because at some point there's going to be so much data that goes into your databases that you're going to have to spread that stuff out, and if you lose a node, it has to be okay. But if you guys have any questions, either about CouchDB, Erlang, Chef, Cloudit, go out and sign up for a private beta. We're sending out invites every day.
Is anyone running memcaches that sits in their cloud infrastructure?
We don't use any. We use Varnish for caching because Couch is HTTP, so Varnish is fast. So, but not in all cases. So, I think as far as memcached goes, as far as at least with CouchDB, is it's totally a client-side thing. So if you have your memcached running on the same server as your application or something like that, and we have caching on our side, and basically you query us and stick it into your memcache rather than the opposite direction. But yeah, if you have any questions or anything, yes, let me know.
Thank you very much.
Thanks.
Thank you.
Thank you.